Hey, hello, Year 8. This is lesson 1 of the new space topic. We are going to be learning about various aspects of science that exists outside of our planets. And the first lesson is going to be talking about how our ideas of the solar system changed over time. So the driving question is, are we at the center of the universe? And the starter question is here are the 8 planets of our solar system. Pluto is not a planet. We will talk about that next lesson. What's the name of the missing planets? Can you name the missing planets? Okay, so it is, of course, Mars, and more about the planets next lesson. Let's talk about the solar system. And this is the way we now currently think about our solar system. This is the current model. The sun is at the center, and the planets and lots of other objects as well orbit around it. This is called heliocentric model. Helio meaning sun, and of course centric because the sun is at the center of the solar system. Now, it wasn't always like this. In actual fact, we used to think of the universe as using the geocentric model. Geo meaning Earth, and centric, Earth being at the center of everything, and everything being orbiting around us. We were at the center of the universe, or so we thought. And you can see that the moon orbits the Earth. Well, that's actually the same as the heliocentric model, but then all the planets and the sun orbit around us, and we are not moving. And then we've got the stars on the furthest most orbit, which are fixed into a rotating sphere. So, I mean, this kind of made sense at the time because, of course, people didn't really think the Earth was moving. They couldn't feel it moving. Everything seemed to be standing still. And observations in the sky were that things were rising on one side and then disappearing on the other side. So they appear to be going around us. So, for example, the sun, which of course is the largest object in the sky, the most noticeable object in the sky, seems to rise from one side, go around us, orbit around us, and then disappear on the other side as it would appear to go behind us. So this kind of made, like I said, this model did fit evidence that people were seeing at the time. Okay, so just to run through some of the evidence then for the geocentric model. So the sun appears to revolve around the Earth once a day. The moon and planet have their own motions, and they also appear to revolve around the Earth once a day. The stars appear to be fixed in what was called the celestial sphere, and that sphere rotates around us once a day as well. And also, the Earth doesn't feel like it's moving. We don't feel like we're in motion. So that also provided evidence for people thinking, well, we must be at the center and everything going around us. So here is the what we call the celestial sphere, which was a sphere that completely surrounds us, and has all the stars kind of stuck in to the inside of it and kind of twinkling and shining down on us. And there's a bit more detail about the celestial sphere. So it's basically just a ball with lots of stars kind of stuck in, like kind of currents in a current bun, so to speak, and they don't move. And this sphere just rotates around us, a bit like the Earth rotates, exactly the same axis. This was called the celestial sphere. Okay, so let's decide this way in which we used to think about the solar system, the geocentric model. Have a read through some of the ideas we just talked about, and which one of these statements is false? Which one is the porky pie, which is East London slang for lie? Which one is not correct? Pause the video, have a think. Okay, so it was in fact B. It is the sun and planets that orbit the Earth in the geocentric model, not the other way around. So the Earth is at the center of the universe. The sun rises and sets is rising and setting is evidence for the geocentric model, and the stars are stuck in a celestial sphere which rotates around the Earth. Okay, so I mean, this was a scientific idea at the time. It was a model. A scientific model is an idea which fits evidence at the time. Now, when new evidence comes along that doesn't fit the scientific model, scientists have to come up with a new scientific model. They have to have a new idea. They have to have a rethink about what's going on. And that's what happened here. We used to believe in the geocentric model, but new evidence surfaced, new evidence was found, and that moved us onto what was the heliocentric model. So here is one of the people, one of the main scientists responsible for finding evidence that didn't fit the current model, which meant that the model had to change. And his name was Galileo, an Italian scientist, and he used a relatively new piece of equipment called the telescope to observe the night sky. So all the evidence so far had been gathered up by using the naked eye, but Galileo was one of the first to start gathering evidence using the telescope. And one of the bits of evidence that he discovered in the night sky were the moons of Jupiter orbiting around the largest planet in the solar system. So he discovered that this planet Jupiter had its own moons, which are orbiting around, itself, not orbiting around us. So this was a piece of evidence that didn't fit with the geocentric model that all objects orbit around the Earth. And this, along with other observations and scientific thinking that was creeping in at the time, eventually was provided the new evidence which gave us the new model, the heliocentric model. Okay, so let's have a pause, have a think about these ideas. Which of these statements is not correct based on some of the ideas, a scientific model, Galileo, new evidence, etc.? Which one of these statements is incorrect? Pause the video and have a think. Okay, so it was, of course, C. Galileo did discover moons orbiting Jupiter, not Mars, and this was the new evidence that didn't fit the geocentric model. So a scientific model is an idea based on evidence. When new evidence doesn't fit the model must be changed. That's right. The heliocentric model was the new scientific model that fitted Galileo's evidence. So let's now have a think about comparing these two models. Here are some statements which are linked either to the geocentric model or the heliocentric model, or both of them. Okay, so can you now write down A to O and then just put G for geocentric, H for heliocentric, or B for both? So, for example, the Earth spins on its axis, giving us day and night. Which one does that fit in with? It is, of course, the heliocentric model. Okay, so H for helio. So just write down the letters and then just put G, H, or B, depending on what the statement's describing. Pause the video now. Okay, so let's go through these. So the Earth spins on its axis, giving us day and night. That, of course, is the heliocentric, the current model of the solar system. The other 5 planets orbit around the Earth. Now, that's the geocentric model. So there was only thought to be 5 planets because, of course, they weren't using telescopes, so they couldn't see beyond 5 planets in the solar system. Earth is in the center. That's the geocentric model. Evidence was gathered using telescopes. That's the heliocentric. Earth orbits around the sun. That's the heliocentric. Explains some of the observations, but not all observations. That was the geocentric model. It didn't explain everything that scientists were observing in the sky. The sun, moon, and planets move in circular orbits. Now, that is the geocentric model. The geocentric model, the orbits were perfect circles. The moon orbits around the Earth. That's both of them. So that's one of the few observations that fit both models. The sun is at the center. That is the heliocentric. J is a repeat of H. Apologies for the mistake there. That's both. K, evidence gathered by making observations with the naked eye. So that was the geocentric model. And then what explains all observations made so far? That's heliocentric. Moon and planets all move in elliptical orbits. Now, an elliptical orbit is like a squashed circle. And that's our current thinking, that orbits in the solar system all move not in perfect circles, but in slightly squashed circles. So they're called elliptical orbits. That's the heliocentric. The other 7 planets orbit around the sun. That's Helio. And of course, Pluto is no longer a planet. More about that next lesson. And the sun moves around the Earth, giving us day and night. That was the geocentric model. Okay, so now here, look, in terms of summarizing the geocentric and the heliocentric model, to get an idea of how they're different. Let's now bring all these ideas together. So for describe, can you describe the heliocentric and geocentric models, please? Sentence starters in red. Then for explain, can you explain how we went from the geocentric model to the heliocentric model? What happened? Sentence starter in red. Then can you have a go at explaining the similarities and differences between the two models? And then can you have a go at creating a short newspaper article arguing for the geocentric model? So if someone, hundreds of thousands of years ago was trying to explain, why the Earth was at the center of the universe, what would that person have said? Have a go at that. Okay, so pause the video, please. Okay, so let's go through these answers. So in terms of describing what the heliocentric and geocentric models are, the geocentric model, the Earth is at the center of the solar system. The heliocentric model, the sun is at the center of the solar system. Explain how we went from one to the other. Well, Galileo used a telescope to discover the moons orbiting Jupiter, which meant not all objects were orbiting the Earth. And this new evidence meant the model had to be changed. We had to have a rethink. Then explain the similarities and differences between the two models. Well, there are lots of differences. The geocentric model, everything is orbiting the Earth. Evidence comes from naked eye. The sun orbits around the Earth, and that causes night and day, and they are perfect circular orbits. However, the heliocentric model, the model that we use today, all objects orbit the sun. Evidence comes from observations using telescopes. The Earth spins on an axis, and that's what causes night and day. And all objects travel in slightly elliptical orbit, that squash circle orbit. Well, what's the same about them? Well, the moon orbits the Earth for both of them. And also, in both models, they used a celestial sphere. Of course, we've got a much better understanding of the way what stars are doing nowadays. But at the time, they kept the celestial sphere for the heliocentric model as well. And a sample answer for the short newspaper article arguing for the geocentric model. So when you stand outside and observe the sky above you, surely it's obvious that all objects are orbiting around us. If the Earth is moving, then surely we would feel it moving beneath our feet. The sun must orbit around us. It rises from one side and gives us day, and sets on the other and gives us night. There is no visible evidence that suggests otherwise. That's an example of what you could have written. Okay, so in terms of understanding how we used to think about a solar system and how we think about it now, can you copy and complete the sentence and justify where you think you are? For describe, can you describe the helio and geocentric models? For explain, can you explain how we went from one to the other? For use, can you identify similarities and differences between the two models? And for combine, can you create an argument for the geocentric model, explaining why people used to think that we were at the center of the universe? Copy and complete that now, please. And you can, now you've completed the lesson, you can also go to show my homework and complete the 10-question quiz. These results will be recorded and will be shared with teachers and parents. Thank you very much, Year 8. Stay safe.